today, a new topic today is line plots, the scaled line plots. And scale just means, right, we decide what we put on this axis right here. We'll talk about that in a second. So follow along with me. You can figure out the scale of a line plot by looking at a set of data. Identify the smallest and largest numbers in your data set. Smallest is called the, say it with me, minimum. Largest is called the maximum. So point to the ground and say minimum. Point to the sky and say maximum. These can be the first and last numbers of your scale, as they've done here, right? And then figure out a way to represent the rest of your data. The numbers on your scale should have the same interval or space between them. Here's this example. Kind of a gross example if you ask me, but it is helpful for line plots. Scientists measured stag beetles in Europe, and I didn't mean to offend you if you really like stag beetles and other insects. Sometimes they gross me out, but that's just my personal opinion. Here are their measurements in inches in order from smallest to largest. So this was nice. This time they gave us all this data from smallest to largest. That won't always be the case. Sometimes the data comes in random order. But all of these different measurements, this is called your data. Say it with me, data. The line plot below shows the data. So obviously if we look at just these numbers, it's really hard to draw any conclusions from those. They're not organized well, and my mind can't make sense of them. So that's why we use line plots, to put a nice visual to the data to help our minds make sense of them. A line plot has to have a title. The title tells you what this is describing, stag beetle length in this case. You also need to label your axis, which means the numbers that you put, what are the units that all those numbers are going to be? Well, you put the units in parentheses, right? Because these are all these numbers down here are lengths, and they're measured in inches. And then once we have our this is called the axis. We have our axis. We've labeled it on the correct with the correct measurements that will match up with our data. And then we went ahead, and each time you had a stag beetle that was 1.5, you mark an X on the line plot, right? So we could see we have 1, 2, 3 X's because there are 1, 2, 3 instances that a stag beetle was 1.5, and so on and so on. You're going to get some practice today plotting data and actually making these X's, but in this example, it's done for you. So let's apply this data to some problems. What is the measure of the longest insect? Well, that means I'll look over here in the right of my axis, and I had one insect that was 3.5 inches, so I can fill out 3.5 inches. Remember, that's called the maximum. Point to the sky and say it, maximum. Okay, now you fill out the shortest. Don't forget your units. Shortest was 1.5 inches. There happen to be 3 of those. So the lowest number in our data is called the minimum. Point to the floor and say it, minimum. Now it says, what is the difference between these measures? Whenever I hear that word difference, I think difference, ding, 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 subtraction. So I know I have to subtract. So I'm going to write the highest, 3.5, minus the lowest, 1.5. Good thing you're pros at subtracting mixed numbers, right? Fractions first, 1/2 minus 1/2 would be 0, so I don't need to write anything. And 3 minus 1 is 2. You also could have used the adding up strategy to see that those are 2 inches apart. This is called the range of your data. The range of your data. Say it with me. The range of your data, which means how far your data spans. Now here's where the line plot really comes in handy. Oops, that was missing a Y. How many insects were 3 inches long? Well, now, again, if this were in random order, this would be really hard to know from here. But in a line plot, it's really easy to see. We find 3 inches, and we can see there were two, what, 2 inches? No, 2 insects, or beetles, you could say, that had that length. And how many were 3.5 inches? You try that one. Don't forget your units. That was just one insect, right? We can see that right here on our line plot. And the most common insect size, again, that's easy to see on the line plot. What's the most common size? Woo, look at that. This one goes all the way up, and that is 2 inches. Well, you will get some more practice using line plots, but they are a great way to represent data.